Hello and welcome in this new video. In this video, we're going to see the solution of question number 10 in assignment 3rd of data science. Question says, why KNN is considered as a lazy learning? Discuss K nearest neighbor. Consider the following table. It consists of the height, age and weight target value for the 10 peoples. The weight value of ID 11 is missing. Predict the weight of this person ID 11 based on their height and age and k nearest neighbor KNN algorithm in this following table. The k nearest neighbor KNN is a supervised machine learning algorithm generally used for classification but can also be used for regression tasks. It works by finding the k closest data point neighbor to the given input and make a prediction based on the majority class of classification or the average value of regression. The K neighbor is also called as a learner algorithm because it does not learn from the training set immediately. Instead, it stores the entire data sets and perform computation only at the time of classification. For the example, consider the following table of data point containing two features in the following given table. Have a new data and category 1 and category 2 data. In the new point is classification is the category 2 because most of its closest neighbor are blue squares and KNN assigns the category based on the majority of neighbor points. The image shows how KNN predicts the category of a new data point based on its nearest neighbor. The red diamonds represent category 1 and the blue squares represent category 2. The new point checks its closest neighbor circled points. Since the majority of its closer neighbor are blue squares, category 2 KNN predicts the new data point belong to category 2. KNN works by using proximity and majority voting to make predictions. What is K in K nearest neighbor? In the K nearest neighbor algorithm, K is just a number that tells the algorithm how many neighbors point of neighbor to look at when it make a decision. Example, imagine you are deciding which fruit is it is based on its shape and size. You compare it to fruits you already know. If K equals to 3, if the algorithm looks at the three closest fruit to the new one, if two of those three fruits are apple and one is banana, the algorithm says the new fruit is an apple because most of its neighbor are apples. How to choose the value of k for KNN algorithm? The value of k in KNN decides how many neighbors the algorithm looks at when making a prediction. Second one is choosing the right k is important for the good result. If the data has lots of noise or outliers, using a large k make the prediction more stable. But if k is too large, the model may become too simple and miss important patterns, and this is called as underfitting. So k should be picked carefully based on the data. A static method for selecting k, cross validation, elbow method, and odd value for k. Distance metric uses in the KNN algorithm. KNN uses distance metric to identify nearest neighbor. This neighbor are used for classification and regression tasks. To identify the nearest neighbor, we use below distance metrics. Elucidance distance. Elucidance distance is defined as the straight line because between 2 points in a plane or space, you can think of it and like the shortest path would you walk if you were go to the direction from one point to another point. Manhattan distance. This is the total distance would travel if you have could only move along the horizontal and vertical lines like grid or a city street. It is also called as taxi cab distance because a taxi can only drive along the grid-like street of a city. With the help of this formula, Minkowski distance. This distance is likely familiar of distances, which includes both Euclidean and Manhattan distance as special cases. From the formula above, when p equals to 2, it becomes the same as the Euclidean formula of distance. And when p equals to 1, it turns into the Manhattan distance formula. Minkowski distance is essentially a flexible formula that can represent either Euclidean and Manhattan distance depending on the value of p. Working KNN algorithm, the k nearest neighbor KNN algorithm operates on the principle of similarities where it predicts the label or value of a new data point by considering the label or value of its k and nearest neighbor in the training dataset from the class 1 and class 2 along the y-axis and x-axis, selecting the optimal value of k. The k represents the number of nearest neighbor that needs to be considered while making prediction. And second is calculating the distance to measure the similarities between the target and training data points. Eliciting distance is widely used. Distance is calculated between the data points in the data sets and targeted point. Third step, finding the nearest neighbor, the k data points with the smallest distance to the targeted point are nearest neighbor. Fourth step, taking average of for regression. When you want to classify a data point into a category like spam or not spam, the KNN algorithm looks at the k closest point in the dataset. These closest point are called neighbors. The algorithm then looks at which category the neighbors belong to and picks the one that appears the most. This is called the majority voting. In the regression, the algorithm still looks for the k closest point, but instead of voting for a class in classification, it takes the average of the value of those k neighbors. This average is a predicted value for the new point for the algorithm. It shows how a test point is classified based on its nearest neighbor. As the test point moves, the algorithm identifies the closest k data point, is it 5 in the cases, and assign the test point the majority class label that is gray label class here. By this data table, selecting the optimal value of k, let's choose k equals to 3. For simplicity, a common default for a small data set. The second step, calculating the distance, we have two features. There is height and age. Targeted ID 11 equals to height equals to 5.5 and age equals to 38. We will use the Leucian distance by the using formula of this. Have a chart are there. Have 5 columns on his table: ID, height, age, weight, and distance of Elucidine, and finding the nearest neighbor sorted by distance. ID 6 equals to 2.02, ID 5 equals to 2.12, ID 4 equals to 4.02, ID 10 equals to 6.00, and ID 1 equals to 7.02. For the k nearest neighbor are ID 6, ID 5, and ID 4. Taking the average for the regression, weight of these neighbors, ID 6 equals to 60 and ID 5 equals to 72 and ID 4 equals to 59. Average of this after calculating the values of each 60 plus 72 plus and 59 upon 3, so it is equal to 63.67. The final predicted weight for ID 11 equals to 64. Thank you.